In this class we are going to discuss about specific heat capacity or specific heat. So to know that, here we have to consider one example. You take two bowls. In one bowl you take 1 liter of water, in another bowl you take 2 liters of water. Put the both bowls on the stove and start to heat them. So after heating 5 minutes, what happens? If you check the temperature of both the bowls, is the temperature same? Definitely our answer is the temperature is not same. 1 liter, the bowl which is having 1 liter of water will have more temperature, and a bowl which is having 2 liter will have less temperature. That means if the mass of the body increases, the amount of heat should also increase. Then only we will get the same amount of temperatures. That means Q is directly proportional to M, where Q is the heat and M is the mass of the body. And you consider one more example. In one bowl you take 1 liter of water, and in another bowl also you take 1 liter of water. Put both the bowls on the stove and now try to heat them. So to get a more amount of heat, I am considering that one bowl should get 60 degrees Celsius and one bowl for 40 degrees Celsius. So what I have to do? So the bowl which should be 60 should get more heat, and the bowl which should be 40 should get less amount of heat. That means to get more amount of temperature, the amount of heat required is also more. To get less amount of temperature is sufficient. That means Q is directly proportional to temperature or change in temperature. So by these two we can consider that Q is directly proportional to M delta T. So to make it equal, we have to bring a constant value. The constant value is here Ms delta T. Here S is the constant value, and here the S is called the specific heat capacity. Here we can write like this: S equal to Q by M delta T, and S is called specific heat capacity. Specific heat capacity means the amount of heat required to raise the temperature of a unit mass through a unit temperature. So that is called as specific heat capacity. And here the SI unit of this specific heat capacity is heat is measured in terms of joules, and mass in terms of kilograms, and temperature in terms of Kelvin. So joule per kg Kelvin. And in CGS unit we can consider that heat is measured in terms of calories, and mass gram, temperature degree Celsius. So calorie per gram degree Celsius. So this is the SI unit, and this is a CGS unit of specific heat capacity. And now if you consider a few examples for the specific heat capacity or some applications of specific heat capacity. First let us know what happens if the specific heat capacity raises or more. For example, you consider two bodies with low specific heat and high specific heat. The body with high specific heat will heats slowly and cools down slowly. The body with low specific heat heats up faster and cools down faster. For example, if you take mercury is having very low specific heat, that is 0.003 calorie per gram degree Celsius. So that's why mercury is used in the thermometers as a thermometric substance. So due to a variation in a small temperature, it expands. So that's why it is used as a thermometric substance in thermometers. So that means it raises fast and it cools down fast. Why? Because it is having low specific heat. If you consider a substance which is having high specific heat, for example, you take water. Water is having a high specific heat capacity, that is 1 calorie per gram degree Celsius. So water takes more time to heat up and it takes very more time to cool down also. So that's why water is used as a coolant in car radiators. In car radiators, when car radiator is heated up, water is used in the car radiators to make it cool down. And so many examples we can consider applications of the specific heat capacity. Consider sand. You know sand, no? Sand is having a low specific heat capacity. So that's why sand is used to heat some ingredients like groundnuts, popcorn, etc. So the sand heats up fast and cools down fast. So when it is put in a bowl and used to heat the groundnuts due to sand will heat up fast, and the popcorn also will fry up fastly. And if you consider water is having high specific heat. Due to its high specific heat, it heats up slowly and cools down slowly. And if you consider our earth consists of most part of water and very less part of land. So due to that, the water or oceans on the surface of the earth acts as the moderators of a climate or temperature. They are moderating the climate and temperature. That means it will not have an extreme cold conditions wherever near the ocean, and there will be no extreme hot conditions also near the ocean. So they are moderating the temperatures. And next, if you consider of water again, see in some cold countries to get heat they use heaters and they made some campfires. If you consider water is also an application for them, so they will have some tubes around the house. In the tubes, hot water is rotated in the tubes to make the room warm. And in the same way, if you consider air also protects us. See, for example, if you in winter seasons we wear some blankets. So what the blankets do? Blankets protects the air from our body not going out. That means our body won't lose heat by the blankets and will feel warm in winter season. So like that, specific heat capacity has so many applications. And if you consider a watermelon which is placed in a refrigerator, and if it is taken out also, it remains cool for long time. The reason is it is having more amount of water content in it. So due to that, the cool remains for a long time. And if you consider a samosa, the samosa inside it, the ingredients is of many water particles. So due to that, even though the samosa outside is cooled, the inside part will be hot. So that is also due to this water content and due to the water having high specific heat capacity. And if you consider some utensils which are used for cooking, they are having low specific heat. So due to that, they heats up fast and they make the food or ingredients which we are cooking and make them to cook fastly. So there are so many applications for this specific heat capacity.